Good morning to everyone. This is Francisco Monteverde, CEO of Collisus Software, and good afternoon to those in Europe. I hope you hear me okay. I have with me David Anderson, business developer at Collisus Software in the US, and he will answer questions during my presentation online. You can do questions, put questions on the screen on the GoToMeeting or webinar applications, so we will handle them as we speak. I hope you can hear me well, and okay, let me get started. Okay, so the title of today's presentation is How DVCS Can Reduce Your Development Costs and Enhance Productivity. And to do that, I include 6 points that I'd like to touch. First one is why SCM matters at all. The second is the problem with SCMs today. The third is development trends driving DVCS adoption. And the fourth, main factors to reduce costs, increase productivity, and software quality, which is the main topic of today's presentation. The fifth is some customer examples where we found that the customers improved productivity, reduced costs, and increased software quality by using a DVCS. In our case, it's plasticscm, and at the end of the presentation, I'd like to introduce you a little bit about plastic if you don't know about it yet. I expect you to know, most of you knows about plasticscm, but I will introduce very shortly so you know what the product is and the latest things that we have. So today's software is almost everywhere and increasing, and probably this is obvious and you know that. But one of the things that's important, the software is everywhere today. Computers, mobile phone, tablets, internet services, video games, consoles, financial services, telecommunications. But one particular thing is that this software, it's built to run in many devices, in many platforms, in many graphical user interfaces. And you need to build this software, the same application, for many devices. That is particularly important when you develop the new software. Moreover, sometimes you build the software taking components from many parts. Take an example of the mobile industry. They take operating system on one side, they take communications operating system on the other side, and they take tens of applications they put on top of a mobile phone as a mobile manufacturer. So they need to put components coming from different places, integrate them all, and test them. That makes software a little bit more complicated than a single application that is run by employees in a large enterprise, for example. Even though in the enterprise it's a trend called consumerization of IT that makes the IT people to deliver applications that run in consumer devices like tablets or smartphones or PCs or in a browser. So again, there's a lot of pressure to build the software to run anywhere in any device. So version control, as you know, is an essential function within software development, and in this environment that this described during the last year is becoming more and more important. So a few years ago, 5 to 10 years ago, version control really was a great thing. It was a delivery mechanism for developers to check in the code that they had finished, they thought they had finished, into a repository. That's what the version control was about, and to store the history. But now it's more important, more essential in software development in these environments that I described that, you know, they are in most of the industry now. So why SCM matters as an example at RIM. RIM at the end of June 2012 declared $500 million in loss. 5,000 employees were sacked, and the BlackBerry 10, the flagship product, was delayed to 2013. That was very important. In fact, BlackBerry is in the news today because of their problems. But the CEO of the company came up that day in June 2012 in front of stockholders, and he said, we weren't able to merge fast enough. And this is the first time I hear a CEO talking about a particular function within the SCM software, and saying that they weren't able to merge fast enough because they developed the platform with so many new features, so many things that was very difficult to integrate. And that is in a statement that was public in Wired magazine and CIO magazine. So it's public. So the thing is, almost 8 months later, BlackBerry 10 was launched. That was in January 13, 2013. So after a long time, if you think about the pressure they had from Apple iPhone or from the Android devices from Samsung and HTC and the rest, this is really a sin. So SCM plays a pivotal role in RIM to be able to succeed. And today they are in problems not related to the SCM, but the whole strategy of the company. But this is a big risk, and that's why SCM is becoming more important these days. Working in parallel seems an obvious productivity gain. Going into the matter that bring us today here, productivity. It seems to be very obvious, and I'm going to go through 2 slides that seem to be very obvious, but many people really don't work this way today. So these are the basics of some of the functions in version control. You have 2 developers that need to work in the same file, same program, and what they do, they just start working. The first one start working in that particular file, and then the second one works, and the time that take to do this modification with these 2 developers are the sum of the 2 times they devoted to this modification, this update, this correction, this new functionality put into one file of the application. Now there is an obvious other way to do this work, which is working in parallel. So you can have 2 copies of the same file, and they might modify the file independently or in parallel. So the productivity gains comes because the total time elapsed is the largest time that one of them took to make his work. That's the productivity gain. Very simple, but now they need to merge both jobs. Both work need to be, because you have them in different files. So you need to merge all work well if you want to gain the productivity that it was shown with the time bars that I showed before. And this is what version control does, and in particular DVCS products does today. So they allow you to work in parallel, and then the version control takes care of merging these 2 modifications. This is very simple, very obvious when you work in the Word document, for example. But if you have hundreds or even thousands of developers modifying tens of thousands of files and thousands of directories at the same time, this is a very complex problem to solve, everybody touching anything. So DVCS products or version control products manage every change and access to these files, allow concurrent edits, that's in DVCS world, allowing parallel or concurrent edits, guarantees merge are correct, and enables coordination among developers. So merging, it's essential to this way of working when you work in parallel, and that is the problem that, for example, RIM had. They didn't have a good merging technology to put all the pieces together. So what's the problem with version control today in this environment? Well, limited productivity, low quality code, and software development today. How do you increase that? But most of the people develop in serial mode, no parallel. Believe it or not, the example I showed before is pretty obvious, but most of the people don't work in parallel. That creates many dependencies and continuous broken builds, because any mistake that a developer does affect the rest of the teams. Second is that developers need to be connected to a central server to use version control. And that creates some problems if they are in the same building, they have a very nice network and a centralized server that works fine, but if they are distributed, They need to be connected all the time. So if the network is not very good, or they are traveling, or they are at the customer site, they might experience productivity problems. They cannot do their work. So today, the vast majority of source code is developed in serial mode using centralized repositories. And this is 90% of the enterprise, as DVCS is only in 10%, 5 to 10%, depending on the analyst in the enterprise. So you've got this diagram, which is essentially a serial development diagram with one branch where the first developer is doing a fixed score in the database, for example, and he checks in the code. The second one comes in and corrects a typo in an about form and checking the code. The third one needs to do a new loading form, and they check in the code. And this is the serial mode. As you see, this is a chain set, the blue bubbles. And every time that a developer does a check-in, you create a new bubble. So what happened here is that these creates many dependencies, because when you test the new loading form, which is the third bubble here, if somebody wants to do something about this, to test this, it has dependencies on the previous changes. And the previous changes, they might not have relationship with these change, but you test everything with the changes already in the code. So not to mention, if this guy, the new loading form, comes in and broke the bill, the next one coming and updating or taking the code to start developing the new function, the new task, has the code corrupted. So he's affected by this serial mode of working. The second thing is that everybody works in a centralized repository. Sometimes when you talked about DVCS, distributed version control, we confused and we talked about the same thing. Serial development and centralized being the same thing, or parallel and distributed being the same thing, and they are different things. You can work centralized and being in parallel, or you can work in serial mode and being distributed. So it's independent, but sometimes the technology are confused. So what problems what we called yesterday's SCMs have when you work in serial and centralized? From technology-wise, the first one is broken bills, as I mentioned, because everybody's working in the main line. Every time that somebody puts something, a bug into the code, or the code doesn't compile, then everybody's affected. The second one is that these type of tools have branching limitations that prevent embrace of agile methods or true parallel development, because at the end you are touching the code and sharing every time you check in your code with everybody else. So for the developers, this is a pain. So they tend to check in code as few times as possible. The third is, you might say that some products, they might say, well, we support branching patterns, but they are arcane and they lock teams. They can't create as many branches as developers have tasks. So Subversion or Perforce are example of those. So, and the fourth is you can't work in distributed manner. So people need to be connected to a central server, and eventually you don't have flexible release cycles because you cannot select what functionality, what fixes, what modifications are going to be integrated into the next release, because everything is being checked in already by developers. So the latest thing have everything else that was checked in before in serial mode. And that creates business problems. The first one is longer development cycles, higher cost, and loss of opportunities. The second being unstable releases, because you have too many bugs, poor quality, and cause delays to market. And the third one is difficult cooperation among heterogeneous teams, like in the gaming industry with artists and coders, or delocated teams and offices, difficult to cooperate between them. Now, these are solved by DVCS, so distributed version control systems. They're mainly focused on solving these main problems. So what we promote is to enable parallel and distributed development with a distributed version control system. And what it does is actually enable parallel development using branching and merging to integrate the code. So in the example I gave you before, There is a fix in the core of the database. This is the main line. This is the first task that it was in the previous diagram, fixing the core of the database. And this developer is using one branch. And in this branch, what he does is work in parallel, and he does as many check-ins as he wish, 1, 2, 3, 4, before getting this code merged into the main line. So what it means is it works in parallel. He can use the version control system without affecting anyone else, making as many modifications as he wants, testing them, and then deciding when to merge into the main line. Okay, the same applies with the second change, another developer, the third, and the fourth. And the flexibility of the system, as I mentioned before, the flexibility of the release cycles is you can choose what to merge at what time. So this label here that indicates baseline 130, this is a baseline, and this includes two changes, this one and this one, but not the database one, because it was considered maybe too difficult, too problematic, and they delay to integrate or to merge this code after at certain time later, and with this one. So this release here includes not only the latest ones, but the previous ones. So you work in parallel, as I said, and the developers' attractiveness is that they can do as many modifications as they wish without doing a check-in into the main line and making their code available or breaking the build. Now, you can do this by working centralized as well, so you don't need to be distributed, but the beauty of the DVCS is you can have distributed code repositories from a server to the laptops or to remote offices or to outsource groups out there. So you can replicate the repositories and have the code replicated so that the system takes care of synchronizes those repositories and be consistent, doing the right mergers between the code when you modify them. That's what, in principle, is the DVCS. It allows you parallel development and allows you distribute code repositories. Now, the main development trends driving DVCS adoptions are four. The first is, as I mentioned, distributed development teams. Teams are no longer centralized. Cooperation among third parties is essential, outsourcers, for example, or different offices. And component-based development and parallel development. That's distributed development teams are demanding a distributed version control system. The second being software as a service or cloud services, because you may reuse many software and services distributed across live repositories loosely coupled. Continuous delivery of features are very important too. So you don't release one application after the other as you do in classical applications. You release features one after the other. So you want to have a lot of flexibility, as I mentioned before, in the release cycle to be able to put in production certain releases, certain features that you wanted to include, not the whole application. So continuous delivery is very important. So working in parallel, testing in parallel, and then incorporating into the main line, into production, the latest feature, the latest thing you want to release, it's very important. Now, between these two distributed development teams and SaaS and cloud service, there is an open source development space that works into that area. So cooperation, open source, they cooperate among distributed teams, as well as component reuse development are inherent to open source development. And that's why it's important in open source. The people is adopting DVCS massively. Now, the other angle, the third one is when you build complex products and when you reuse components, you build smartphones, you build games, you have embedded software. And I give you an example. And Android applications need 2,000 different versions to run in the different devices that exist in the marketplace. And iOS applications needs 40, which is a lot, still a lot. Component-based development is essential, and delivering your code to different platforms, have different versions for those, is essential. So the complexity of these products require parallel development, and having flexible release cycles and control this. Now the other one is agile development, and implies faster development cycles, incremental releases, parallel development, and branch per task. Okay, I have a note here. Now between the second point and the fourth point, you may find another trend right now, which is DevOps. And sometimes also continuous delivery falls into this category. And DevOps embraces agile principles, and hence flexible incremental release cycles are needed. It's connecting the operations, the feedback from operations and the user back to the development team, for the development team to respond immediately to those requests. And it supports branch per task or parallel development. The support for branch per task or parallel development is fundamental, is essential for speeding up the development operation, the DevOps paradigm. All these trends collide into the DVCS adoption because they respond very well. I'm not saying the DVCS is for everything, but if your development teams falls into some of these problems, you likely be benefited by using a DVCS product, a DVCS version controls. DVCS version control system. In fact, Gartner Group said last year that distributed versioning is at the peak of expectations in application development. In fact, most of the ALM manufacturers today are thinking or implementing some sort of distributed version control mechanism in the ALM frameworks. That's distributed versioning at the peak. The year before was at the half of this curve on the left. We came here to talk a little bit about reducing cost and increase productivity and quality. So the main drivers to reduce cost and increasing productivity and quality in DVCS world are those. A, reduce cost. First, because the licensing, the installation, deployment, training are lower than traditional centralized SCM systems. This is very, very important. Second, the infrastructure is minimized. The server horsepower, since work can be distributed, you can put as many servers as you wish, whether in one location or different locations, and there is no need for the central server to cope with everything, with all the load of all the developers. You can split that in different servers so they can connect, and the system can be synchronized. And we have requests for this in the gaming industry, for example, where they have large binary files distributed across teams across the world, and using large code bases. And so the infrastructure is lower by using a DVCS system by far, not to mention the other factors that we will discuss later. The third is merge responsibility to the most knowledgeable developers or dedicated role like an integrator role, thus significantly reducing the total merge effort done by the developers. The increased productivity column indicates that first, enabling parallel development, reducing overall time to complete a release. Moreover, it significantly reduced broken builds. So enabling parallel development is very, very important. The second one is merge efficacy, reduces manual interventions. Because if you develop in parallel, at the end you will need to merge, as I explained in the first slides. You need to merge. The more efficient you are at merging, the better productivity gain you win. So we work in our company in making merge very efficient, because that's the key. You can work in parallel, but if you do merging really bad or not in a good way, you would enter into manual intervention, and that will lose the gain that you got by doing parallel development. The third is enable working remotely or offline to central server from anywhere. That increases productivity too. Work can always continue regardless of the availability of your network. And we find customers that have, for example, there are consultancy firms that they need to go, or development teams that need to go on customer premises and to change the code. Sometimes they cannot connect to a central server to be able to access the version control. So by using a DVCS product, they can do that, do the changes, and then synchronize afterwards when they have connectivity. Experiences significant performance gains because work is done locally with no network, latency issues, or server bottlenecks. The fifth is work with your desired workflow. These tools are very flexible rather than dictating a particular workflow. And that is particularly important and also recognized and appreciated by developers. And fifth, in the sixth point, enables point-to-point communication between developers, not requiring a central server to collaborate, as developers can be connected to their own repository locally or in their office, in the branch office. They can connect to each other and work collaboratively. And the last point is enhanced quality. So flexible release cycles allowing to select independently what changes need to be included or merged in a particular release, as I explained before, that increase quality because you can test your changes before you merge into the main line. And the second point permits the developer's work to be completed locally without affecting other users until the developer has completed all work. And this is visible to the managers. This is visible to the teams. They know what a developer has done even when he hasn't checked in the code into the main line, merged the code into the main line. It's in parallel. It can be seen. It can be monitored. And the third point is you can run code reviews. You can do unit tests that can be passed at a task per branch level, at the branch level before merging, and merge is complete to the main line as I mentioned. So these are the main drivers: reducing cost, increased productivity, and quality. And this is not theory. I can tell you we have customer examples that have proved that. I will not mention the customer name because it's a very large one and they don't allow us to give the name. But if you want to talk to me at the end of the conference, or you can send me an email, I can share some data with you if you're really interested. But this is a software manufacturer for a 540 company. They use agile methodologies and branch per task in the development of large operating system components. So they increase productivity and ease of adoption within the team by completing these 3 points. First is efficiency. Efficient because by using a DVCS, our product in this case, it requires 2 to 3 minutes a day of interaction with the developer. When other SCM tested, including some DVCSs, required from 30 to 50 minutes per developer only to include changes made outside of the SCM tool. That meant that they changed code, they changed files, directories, and things outside of the SCM control. So our product, for example, detected those changes automatically, so they didn't need to do any manual work. The second is fast and efficient. So bad mergers or manual mergers that need to be resolved manually take 5 minutes a day by developers with the new tool. And the previous tool taking 50 minutes a day in average to resolve the bad mergers they had because they work in parallel. So, and then the third is easy of adoption. plasticscm, the branch explorer, and having a graphical user interface help them to include new developers in the team, increase the number of developers, and get familiarized with the tool in 2 to 3 days. So very easy to manage it. And so the impact on business for them by adopting a system like this, in total, the project of 6 months saved 1 month of this time. And they automated the process of merging and testing by using a continuous integration tool. They put all the triggers to have a cooperation between the new SCM tool and continuous integration tool. For example, they didn't allow anybody to merge into the main line. It was the continuous integration tool. Once that any particular task, any branch was flagged as tested, as finished, and being reviewed, then the continuous integration tool did the merge automatically. And that's why they could really go really fast. They said that to do a release with the previous product they had, it took them 3 days, from Monday to Wednesday, to have a full release out. With implemented the DVCS product, our product, it took them one morning, starting at 9 o'clock. By the time they went to lunch, they could release they have the new release out. They could do all the mergers all the way up from any branch they had open to integrate it and have it the final release. So in this context, developers save more than 100 minutes a day in just 2 operations, declaring changes outside of the SCM and made more efficient the merges they had to do. So that makes a 650K return on investment in a year for 35 highly skilled developers. This is a high-end group of people. They're not juniors. They're mostly senior developers working in the team, and they measure this as 20% increase in productivity. I have other examples too, which development productivity gains translate into business metrics. And I'll give you 2 examples. One is Pantech. This is the second largest mobile manufacturer in Korea. So they had a very large SCM system. And as you know, when you build mobile phones today, in this case, they had more than 50 Android devices they manufactured to 30 operators worldwide. So to build a smartphone with Android operating system, they need to bring the code from Android from Google. They need to bring the operating system for communications from Qualcomm. They need to put on top tens of applications from, the clock to the calculator to the camera, the video. Every application you can think of that a smartphone has need to be delivered through third parties, and they develop some part of the firmware of the phone. So they need to put all this together and then update this every week, every 15 days. They need patches from any of these contributors. So this is a very complex sourcing of software. So and they need then to deliver this in different devices, different form factors, different screens, different capabilities. So the components for each of versions of those components for each of the phone is different. So one of the problems they had, for example, is Qualcomm delivers a patch every 15 days. A patch from Qualcomm includes 250,000 files, thousands of directories, and it took them 18 hours of CPU plus a lot of manual work to be done every time they received this in the previous SCM system. We tuned the DVCS system which is very good at merging, to lower the time to 3 minutes, from 18 hours to 3 minutes. It's not only to do it faster, it's to be more efficient in doing the mergers. So today, what they've got is better time to market. When I ask them, what was the gain that you actually get? And they say, well, we have more updated devices in the marketplace. When you go to an operator, the last thing they want to have is a phone or a smartphone with old versions or very old versions of the software, 6 months, 4 months old. This is not acceptable. They are deploying today 4G or LTE networks. They want to have the latest Qualcomm software into the phone. So what you need to do is to be very, very efficient, and that comes back to the RIM problem. You need to integrate all those components and be efficient in merging all those and testing them. So that is time to market. That's what Pantech gained. Pantech has more than 1,200 developers, or even more, that work all against the same code. They don't have different projects. They mostly work into the same code at the same time. So the scalability of the system needs to be very high. And the number of branches and mergers they do every day is tremendous. It's crazy. I can think of a few companies in the world that can do, or industries that need to do so many mergers, so many branches in parallel at the same time. So, and we succeeded by implemented our DVCS product in their market, in their territory. They are in South Korea and Seoul. So if you have any of you want to know more details about it, I will be happy to talk to you about. The other one is HP. And HP is a different paradigm. They have a healthcare division that they develop a software to manage hospital information as a hospital information system and manage the clinical part and the administrative part of the hospital. So they have many customers, which 90% of the software is being delivered and is being used in the same way, but 10 to 15% of the software is customized. So the problem they've got is they need to maintain different versions for different hospitals. In the same case of Pantec, they have different devices. In this case, they have different hospitals. And the problem with this, which is different than Pantec, is every time they go in a hospital and change the functionality, and they want to deliver that functionality to the rest of the customers, they need to do these, merge those changes into the rest of the code of the rest of the customers. If they fix a bug centrally, they need to deliver that bug fix into the rest of the code of the customers. And what they did is they created different branches per customer with different versions of the software, and they managed this back and forth flow of code from different branches with a DVCS product, which is very efficient. Before, they used a centralized CVS product, and they were not efficient at all. It was crazy. By the way, Pantec used IBM ClearCase before, and we managed to lower the time to do mergers by several orders of magnitude. Okay, these are three examples. The first one being a large software developer in the operating system business, Pantec and HP, and we have many cases. The problem with measuring productivity and cost reduction, unless the cost reductions is about licensing price and things like that, productivity is very difficult to measure because there's not historical metrics around productivity, and it's difficult to define as well the units. So to finalize my speech and to give some room for questions and answers, I will introduce you a little bit about our DVCS, which is plasticscm. So Plastic is our product, as you may know. What it does is branching and merging very good. We are the only commercial enterprise distributed version control system. For teams of any size, we have very small teams, a few people, to large teams of more than 1,000 developers. In the case of Pantec, working all in the same code at the same time, which enables parallel and distributed development that really works. And we have a testimony here from Gartner Group that put us in the cool vendor list a couple of years ago when we just started to make it bigger, the product. And we have the eWeek editor in July last year calling us the Cadillac of the SCM as they test the product. And they found that we pay attention to many details on the product, not only parallel and distributed development, but many other features inside it. And also we have mentions in blog sites that you can search and Google it in the internet. So why plasticscm is different from any other product, even the DVCS product you might find in the marketplace. And the first one is because we are fully distributed. We support fully distributed repositories to the point where every developer can have a repository on their laptop, but also we can work centralized. And if an industry or a customer wants to work centralized, we can do the developers to work in parallel, but against a central repository. We can mix both two. And also we can replicate partially some of the repositories. So if you have an outsourced partner and you don't want to replicate it, you don't want them to replicate everything on the code, you have partial replica in our product, so you can replicate partially. So that's a unique feature too. The second is, and this is the trick of gaining productivity, is branching and merging, which is simple but very powerful. And you may find on our website an explanation under, you can link a merge machine, as we call the page, and you can go through our main page and look at it and give you all the different merges that we resolve and even compare to different products in the marketplace. You can see that we invested 60% of R&D in making merging really very efficient. The third is the curve of learning of these products. It's high sometimes, but when you have a rich graphical user interface, as we do, it's very easy. And an example I give you of this Fortune 500 company, it took 2 to 3 days for somebody that was working with an SCM product to switch to plasticscm and consider plastic one of the best things they have worked before because it has the graphical user interface. Also, you can work with command line interface. The fourth is that these products, the DVCS products, are usually criticized but not being secure. And we have security management of the source code and even auditability. So we really set apart from the rest of the products in the marketplace in that respect. So we connect with Active Directory, we connect with LDAP directories. You can define all the groups and users. You can define what actions can they do, and also what repositories can they access. Everything can be defined, to be honest. Finally, we stored everything in repositories on relational databases of your choice. So that gives in the enterprise to the IT operational people a way to easily manage the SCM tool because they can provide high availability. They know how to do backup of the database, hot backup, or replication, high availability, or reporting services against the structure of our database. So they can include these reports into the statistics of the development team. Now, we have also embraced open standards and drive innovation. We released in April a mechanism to synchronize with Git. So we replicate anybody using plasticscm can push and pull code into Git repository. So eventually you can push and pull code to GitHub, to Microsoft Codeplex or Atlassian Bitbucket, or to your own Git repositories if you have any. So you can work collaboratively with repositories based on Git. Innovation, and that is very important because not only we do classical merging technology, which is syntactic merge, without understanding the language. That's what everybody does. You do a merge comparing line by line, and comparing files and do the merge after that. But we release semantic merge. It actually is the unique language-aware merging technology that exists in the marketplace. We release the product in beta for C# or Visual Basic .NET for Java, and we are about to release for C, C++, and JavaScript. That's our plan. So it enables refactoring because if you want to do a big refactor, what people usually does is to stop the developers from working, do the refactor, and then they continue to work. With the semantic merge, refactors are very easy to do. The tool merge that automatically, and you can continue to work in parallel while you do the big refactors. So that enables companies to or teams to do refactoring more frequently. That means increasing quality code. And excellence, the third point, because we do a very strong merge technology, the classical one that I mentioned that you can find here in the link, the merge machine page. You can find examples of what we do with the merging technology. So we think that we provide value to different roles. For developers who love the freedom of distributed and simple branching and merging, that's inherent to any DVCS product. For managers, because we provide a means to lead distributed teams, to manage access, to understand the project status, the status of the development. And for release builders, because they can create stable software releases and flexible software releases, as I spoke before. Some of our customers worldwide, we have blue chip companies like Sony, Microsoft, Pantech, HP, DHL in Europe. We have many already working this paradigm, and we have, especially in the US, a lot of press following up. eWeek, Dr. Dobbs, Gamma Sutra in the gaming industry, InfoQ. And by the way, we're going to be in this conference, QCon in San Francisco, from the 11th to the 13th of November, so in a few weeks we're going to be in that conference sponsored by InfoQ and SD Times as well. So our company, College Software, if you are not our customer, what we promise is proven technology, leading DVCS implementation, customer focused. We have a professional support behind us, but also we provide customizations for several industries like gaming, mobile, and things like that. We are open to listen and being customer focused in delivering the features and characteristics that you wish in your company. And strive for excellence, because the only thing we do is a DVCS product. We don't do issue trackers, we don't do continuous integration. What we do is integrate with all of those ALMs or surrounding products like IDs, Visual Studio, or Eclipse, and we integrate all of those, but we concentrate our efforts in doing the best implementation of a DVCS product in the marketplace. That's my presentation for today. I thank you very much for your attendance, and I'm open to questions. Okay. Open to questions. If you have any, I'll be more than happy to answer. I will wait for some time. Otherwise, here is my my email, Francisco Monteverde fm@codisoftware.com. If you want to contact with our sales team, so our email to the sales team is sales@codisoftware.com too, so you can reach us. Okay. I don't see any particular question coming up. Let's see. Will the slides be available online? It's a question from Malcolm. Yes, we will put them online later on. We will give you the link of those. We will publish a broadcast, this broadcast on, and we will send you the link to download it or access it online. Okay, let me see if I have any. Okay. There is a corporate concern over DVCS lack of asset control. Okay. Let me see. Okay. Well, I'm not sure what it means by asset control. I think DVCS, although it's distributed, it doesn't mean the people are disconnected all the time and taking all the code or asset away from the control of the managers, the project managers. So as I said, one of the things that you might want to do is sometimes when you have sensitive project is to put everybody working centralized with a central repository. If your project requires that, you can do that with our product. It's true that DVCS, pure DVCS products, they replicate everything. The second thing I mentioned is you can do a partial replica of the code, so you can protect part of the code, not replicating, not allowing replication to anyone else, either internally or outside of the firewall. The third point is that being distributed doesn't mean not being in control of the assets. So you have everything monitored. How many check-ins a developer does, even working in parallel, or what code has been modified, what product, what files. You have all that information centrally, so you can control that. I don't know if that answered the questions, but it was. If you have further questions related to that, please post that into our window or contact us directly. I have a question. I think I answered those. Which language supports semantic merge? We released the beta version of the product with 4 languages already, which is C#, Visual Basic.NET, that's a Microsoft World. We have Java, and then we are about to release C and C++ and JavaScript. In fact, there are posts around JavaScript in our website. You can go to semanticmerge.com is our web page with semantic merge if you're interested. Okay. Hopefully I'm not missing any question. Is there some document? Another question from Sander. Thank you very much. And by the way, thank you, Greg, Malcolm, for your questions. Is there some documentation available for recommended practices for Xlink, a repo reuse? Yeah, there is. I think if you go to our blog page, we release some documentation. There is a documentation page in our homepage. You can go documentation, and there you would find Xlink's user manuals. So you can look there. Some practices about the architecture and how to use it. Secondly, I think you can find information in our blog, which is more informal about the practices of using Xlinks. And if you have any questions, again, send me an email, send us an email, and we'll come back to you with our support team. We will provide you that information. But yeah, there is something that people, the Xlinks is using, especially, for example, in Pantic in Korea, and this mobile manufacturing, they use a lot the Xlinks because they use component-based development. You can imagine in the mobile phone, think about the camera application. They have the camera application that need to be delivered to any phone, but the cameras might be different. So they have a component that have different versions as well. So camera for phone B, phone A, or phone device A, device E, device C, they might have different versions of the same camera. But they have a repo with the camera code. So every time they need to update that software, they do it, and immediately all the code, because Xlink is linked to that particular component, is changed in the next release. That's why they do that. And we have also different ways of using the Xlinks, whether are writable or read-only. So you don't want people to modify these components, or only authorize people to modify the components. You can have them read-only or writable, so anybody can really touch them. Okay. Thank you, Sander. So we are on time, and we are 8 minutes before the planet time. So if you don't have further questions, I will finish the webinar here today. Again, if you think about using plasticscm at all, so just contact us. If you have further questions, please contact us. Okay, thank you very much. Good morning to anyone in the US, and good afternoon, good evening to anyone in Europe, and if there are anyone in Asia, good night. Thank you very much, and talk to you next time. Thank you also for your feedback. If you have any feedback, please let us know. Okay, thank you. Bye-bye.